of motion, that is NLM. In this one, the basic some of the sums regarding the basic fundamental Newton's laws as a connected body system, block on a block on the friction and inclined plane. So these things we'll be discussing over here. So please. Now coming to our first question, it's an so block A and block B of masses 2 kg and 4 kg suspended from and through a string using a pulley inside an elevator moving downwards with a constant acceleration A. So the system is moving in the downward direction. It's an Atwood machine condition. So tension in an Atwood machine can be written as an 2m1 m2 by m1 plus m2 of this will be the g, since it is coming in the downward direction, g minus u. So if you can remember these formulas, you can go ahead, or else you need to derive this relation for the tension and we need to solve them. So or else this can be 2 into the mass of this one 2 kgs and 4 kgs by 6 into g value. If I take it as an some 10 minus 2, that's going to be the 8, and this will be the 16 by 6 into 8, or 3 times and 4 times, it is 64 by 3. So this is our so first question. So Atwood machine condition and acceleration under the Atwood machine can also be obtained as a is equal to the greater mass, or if it is m1 minus m2 by m1 plus m2 of g. So these things, if you can remember, it will be comfortable for the student to solve in the examination. A man is standing on a rough horizontal sun, a rough horizontal disc, rotating with an constant angular velocity of omega. He has given at what distance from the center should he stand so that he does not slip on the disc. So a person or a disc or a block or whatever may be the case, it is been on on a disc on the rotating platform like this. So now suppose if he doesn't want to slip over here, so the force which is going to be acting towards the center will be your frictional force, which is in the place of your centripetal force mr omega square radius. So frictional force is going to be the mu into n. In this situation, your normal reaction or the contact point is going to be the upward, balanced by the downward force is going to be the mg. So that will be the mu mg is equal to mr omega square. So mass can be removed here. Coefficient of friction 0.2, 1 by 2. I'm taking this is 10 is equal to radius. We need omega square is pi square. So this goes for 5 times. So 5 will be left to 5. 5 can be cancelled. The radius is equal to 1 by 5 in the sense it will be the 0.2. So if it does not have to, that means omega mr omega square has to be less than this one. So if I consider this entire relationship, or if the friction is greater than this particular thing, it does not fly off. On that section also you can write, so radius has to be the less than this particular. So you can go for the first option here. Next one. A constant force is there, 750 newtons is applied on the block of mass 1 or 2 kgs. To prevent it from sliding on an inclined plane, on a sliding, okay, so what is the angle of inclination? He has given 30 degrees with the horizontal. If the coefficients of static and kinetic friction between the blocks are 0.4 and 0.3 respectively, frictional force acting on the block he is asking. Now to prevent it from the sliding is not, that's okay, no problems. So what is the when it is start sliding? We need to first verify whether it's going to be sliding or not. For that one, we have to check the limiting friction. FL is equal to, that is the limiting friction. That is the maximum value of the static friction mu s into mg. So what is this mu s into mg? Mu s value is 0.4 into mass is 102 into G value. Let me take it as some 10. So that means it will be 4 into 102 here. So it can be equal to the 8, and this one is going to be the 4, not 8, something like this. So static and this is the maximum case. But the applied force is going to be definitely greater than this particular thing. So, and what is an kinetic? That means it's going to be starts in the motion. Then what is the friction will be kinetic friction Fk into we can go for the okay since it's in the inclined plane, sorry, since it is on the inclined plane, then the normal reaction should be the cos theta thing, and I'll multiply this one with the cos 30, that is root 3 by 2. If I divide this one 204 into root 3 value 1.732, so this may be approaching towards somewhere around nearby 340 or 350 it will be. So it will be in between the around 350 if I consider them nearly equal to this one. So applied force is 750, which is going to be the greater than the maximum static frictional force. And in this case, mu k into mg cos theta we need to consider. Mu k, that is a since it's been under the motion, kinetic friction will be there. 0.3 into 102 into this is the value of this one is going to be 10 into cos 30, which is equal to the root 3 by 2. Sorry, it is going to be the 5 times. So multiply this one, this will be the 15 or 1.5 into 102 into root 3 value 1.732. So when you multiply this particular thing, this value will give you the frictional force. So most probably it should be 3 by 2 in the sense into this is 102 into 1.732 comes out to be the 51. The value is going to be the 153 into 1.732. So it should be nearly equal to some 200 around. So the better answer is going to be the 250. Next one, the block of mass 1 kg is at the rest on a horizontal table. Coefficient of static friction between the block and the table is 0.5. So mu value he has given initially it is in the rest means initial velocity is equal to 0. Acceleration due to gravity is equal to 10 meter per second. Then the magnitude of the force acting upwards at the angle of 60 degrees from the horizontal. So he is asking the force is going to be how much and what is its particular value. So what is the minimum force will require any particular thing. So this is a situation where you are going to be minimum force will require the pulling this one. Angle is theta, so it is going to be the F cos theta here. And your vertical component will be the F sine theta along with that one. Normal will also be there, downward direction mg will be there. From this situation, a normal reaction can be written as an mg minus f sine theta. For the minimum condition, applied force that is f cos theta should be equal to the mu into n or mu into this is mg minus f sine theta. So from here, this is f cos theta is equal to mu mg minus mu into f into sine theta. If I take it to the other side and write it, f will be mu mg by it will be the cos theta plus mu sine theta. So this is the minimum force that's going to be needed. So when you put it down in your corresponding these values, mu value has been provided, mass 1 kg, g is also given, theta is also provided to us. When we substitute all these values, we can find out that particular force is going to be how much. Fine, next one. A 100 grams iron ball having a velocity of 10 meter per second collides with a wall at an angle of 30 degrees. The angle with respect to the wall and rebounds with the same angle. So the period of contact is going to be the time period is going to be 0.1 second. So it's going the contact of the ball and with the wall force experienced in this one. In this case, according to the Newton's second law, force experienced is equal to change in momentum by time. So for this case, suppose if we consider this to be a wall, a vertical wall is there like this. So a ball, this will be normal to the wall, and a ball is coming and hitting the wall with an angle of 30 degrees to the wall. In the sense with respect to the normal, it will be 60 degrees. After hitting it, it is coming back with the same angle. So this angle should also be 60 degrees. Then while going towards in this direction, it will be the u cos 60, and returning also u cos 60. So momentum are in the opposite direction. So then force can be written as an F is equal to change in momentum 2 mu cos 60 by the time of contact of the ball with the wall. So it is 2 into 100 grams, 100 into 10 to the power of minus 3 into initial velocity is 10, and the cos 30 will be root 3 by 2. And this is going, so sorry, it is cos 60. So on that sense, it will be the 1 by 2 or 0.5 if I take it, and the time of contact is going to be 0.1. So 2 to remove here, this is 10 to the power of 3, these will be cancelled, and 1 by 0.1 is nothing but 10 newtons. So this will be your condition. Next, the velocity of the body of mass m is equal to 20 kgs decreases from 20 meter per second to the 5 meter per second in a distance of 100 meters, force acting on the body. So if I need to find out the force, F is equal to, I need ma. So we need an acceleration value since we have got the mass. So if we can find out the acceleration, since velocity is decreasing with an initial velocity u to v, that means it is a retardation case. And distance traveled, yes, has been given. So we can go for an equation v square minus u square is equal to 2as. V square will be 5 square minus 20 square is equal to 2 into acceleration into 100. So this will be equal to how much? From this one, acceleration A is equal to, so minus 25 minus, this is 400, so minus 375 by this is 200. So this is our acceleration, and substitute in the force. So F is equal to ma minus of mass is 20 kgs into 375 by, it will be 200. So let's go for this as a 10 times, and this will be the minus 37.5 newtons. So this is our option. Now coming to a block E is moving up the inclined plane. Angle of inclination is 60 degrees with a velocity of 20 meter per second and stops after 2 seconds. So how much time after which it has been stopping? Fine. So who is stopping that one? The friction is going one, which is stopping it. The G is appropriate coefficient of friction. He is asked. Angle of inclination is there. There is an inclined plane where the angle of inclination is 60 degrees. Since the block is moving up the inclined plane, final velocity is equal to 0. Initial velocity is equal to 20 meter per second, and coefficient of friction should be in this direction. Fine. Now, what is the acceleration that is going to be offered here? V is equal to, if I go for u plus at, final velocity is equal to 0, initial velocity 20, and acceleration is equal to, that is plus a into 2 seconds. So from here, acceleration a is equal to minus 10 meter per second square. But since the block is moving in the upward direction, acceleration value is going to be g of sine theta plus, this is mu cos theta. So acceleration is 10, g value is also 10, is equal to sine theta plus the refractive index value, that is mu, this is the one he is asking, and angle of inclination is, this is 60 plus mu into cos 60. So on solving this equation, or this is 1 is equal to root 3 by 2 plus mu times of 1 by 2. Okay, if I take the LCM, it will be the 2 is equal to root 3 plus mu. So just we need to solve that one. Mu is equal to 2 minus root 3, which is 2 minus 1.732. So this is our final thing. If I remove something, 2 minus of 1.732, the value should be around 0.33, or this will be less than that one, that is 0.27, like this it will be. So this is our better option. Next one, a block, a 10 kg block is there, is placed on the top of 40 kgs block as shown in the figure. A force of 100 newtons force F has been applied and it is moving with an acceleration of the 2 meter per second square. For this situation, mark out the correct statements are going to be how much. So since it has been moving, what will be the acceleration also he has provided to us? Or else you can also get the acceleration condition. So in this case, since the bottom block is been pulled, A fields and pseudo force. A fields and pseudo force with the acceleration of the system. What is an acceleration of the system is 2. So that means pseudo force is equal to m into acceleration. Mass is 10 kgs into acceleration system 0. So 2 meter per this one. So it is going to be experiencing 20 newtons. If this value is equal to the mu mg, then we can get this one, where mu is equal to 20 by mass is how much? 10 kgs. That is 10 into 10, which is 1 by 5 in the sense 0.2. So this can be maybe the value of the coefficient of friction. Wow. This is another one. It's a very lengthy sum basically. If you get these type of the questions in the examination, then just leave it and just go forward for this one. Excuse me. So all the blocks are equal masses of this one. So masses are the same. All the surfaces are also smooth. Find the acceleration of the sea with respect to the ground is. Let us imagine that acceleration of the sea is it's moving in this direction. Okay, let me take this as a C only, and this is the B, and this is the direction of your A. A is coming in the downward direction. So what is A? Let me define these things. What is A? A is acceleration of block A, that too with respect to ground. B is also acceleration only, acceleration of the B with respect to inclined plane. C, next one. It is the acceleration of the C, that too with respect to ground only. This is also fine. So this is the information that we have, please. So in this case, what will be happening here? We have to find out the resulting. So since B, we have taken it as an acceleration with respect to the inclined plane. So that means B should be equal to the with the acceleration of the B purely and minus acceleration of the inclination. So that means B plus C should be equal to what? It is the acceleration of B with respect to ground and coach kada. With respect, so these are the terms that initially we have defined here, please. So on define, after defining them, we need to obtain the relation between them. So if we apply the force equation here, apply the horizontal condition. Horizontally, one of the acceleration is in this direction. Since it is theta, B cos theta should be in this direction, right? So now, what sort of any formula that is the resultant force? F can be written as N, or force on the B is equal to, this is mass mc minus, this will be the mb cos theta. So this is only horizontally I have taken. Now coming to the other case. So what are the other situations that we can face here to obtain the relation between the B and C? So from this one, this is FB. Now force on the C is equal to mass into C. This we can write. So this is the force which is acting also in the horizontal sense. So if we apply this particular thing onto this one, that is, this is equal to the MC, or if I add these two things instead of going in that way, so we'll be dealing in another situation like this. So just try to add these two things, please. Force on the B and this is the force on the C. So on that sense, we can write it as an horizontally, please. Both the form, that is MC2, MC should be net force. This will be equal to 0, is equal to, this is MB cos theta, and the relation between the block C acceleration and the block B is 2C is equal to B cos theta. First information, and second information, acceleration A is equal to B sine theta. So from this one, we can get the information, or from this one, C value is equal to B by 2 cos theta. This is the what he has asked in this one, acceleration of the C with respect to the ground he has. So to write the C is equal to B by 2 cos theta, we don't have the B value. So for that one, I have to determine the B value. So now applying the NLM conditions, that is, applying Newton's laws of motion. So what will happen here? 2mg sine theta is equal to m into 2mg. Why 2mg sine theta? The total force that's going to be acting in this one, this mass plus this mass. So 2mg sine theta should be equal to the opposing forces of this one, mb minus c cos theta, plus this is going to be the ma sine theta. So these are the forces that will be acting at that particular instance. So these are the balancing situations, please. From this one, you can write it as an, this is g sine theta is equal to, this is b minus c cos theta plus a sine theta. So this is the different equations, please. Now from this one, get the relationship between the b and the c and try to eliminate the a. So how do we eliminate the a here, please? A can be written as an, in another format, b sine theta. As I have mentioned here, a is equal to b sine theta. Replace the a is equal to b sine theta here. So that will be combinedly called as an, uh, that is b of 1 minus cos theta. This is equal to conditions I have written. From this one, the next can be written as an, this is 2g sine theta is equal to b minus cos theta plus b sine square a, or sorry, sine square theta. On solving these issues, we can get the value of the b is how much? So once you get the value of the b, you can also find out the value of the c. So that means on solving this one, all the values are in the b terms only, b only you can find it out. After finding b, we know the relation between the b and c is how much? 2c is equal to b sine theta, or c is equal to b by 2 sine theta. So this is how you can find out the relation between them. It's a lengthy question basically. The block of metal weighing 2 kgs is resting on a frictionless plane. It is struck by a jet released from the water, in this case, the initial acceleration. It's a variable mass, F is equal to relative velocity into dm by dt. So F can be written as a mass into acceleration, ma is equal to. What is the velocity with which relative velocity is 5 meter per second and dm by dt is 1 kg per second. So from this one, ma is equal to how much it should be? The 5 only. You can apply the 5 and weight mass is 2 kgs. So acceleration is equal to 5 by 2, which is equal to the 2.5 meter per second, right? This is our initial acceleration conditions. Next one, a man and a sun, man mass each, sun mass each, both are weighing over there something. Mass is going to 50 kgs, 20 kgs are standing on a frictionless surface facing each other. The man pushes his son. The man pushes his son so that he starts moving at a speed of 0.7 meter per second with respect to the man. The speed of the man he is asking. So according to the relative theory, velocity of the sun with respect to the man is equal to velocity of the sun plus velocity of the man. So these two are same. Next one. The velocity of the sun with respect to the man, this value he has provided 0.7 meter per second. Next one. How do you find out the velocity of the sun? How do you find out the velocity? How can I replace basically the velocity of the sun? So can next one, another one, like the speed of the man. So how do we get that relation, sir? The man's weight he has given this one. Man pushes and starts with respect to the man. Also, this information he has also given to us. So how do we? Because man is standing the sun on an frictionless surface. If the man pushes the sun towards the right side, then he himself move towards the left one. So on that sense, you can go for the conservation of the momentum. M1 V1 is equal to M2 V2. M1 is going to be the 50 kgs. V1 is equal to 20 kgs into V2. So from here, V2 is nothing but what? Velocity of the that is if I shift it V naught into Vm is equal to 20 into velocity of the sun. From this one, if I want to replace the velocity of the sun is equal to 5 by 2 into velocity of the man. So substitute here, please. This is going to be the 5 by 2 into velocity of the man plus velocity of the man. So velocity of the man is equal to how much it should be 7 by 2. This goes to the other side. 1.4 by 7 into Vm. Okay, so that means velocity of the man will come down to the 0.2 meter per second. So now next one, two blocks A and B of masses M is equal to 1 kg and MB is equal to mass of the A is equal to 1 kg. Mass of the B is equal to 3 kg are kept on a table in figure. Coefficient of friction between the A and B is, so here the coefficient of friction is 0.2 and here the coefficient of friction is, that's also 0.2 between the block and the table. So minimum value of the force he is asking, so applied on the B horizontally so that the block A does not slide over the block B. So for this to happen, what should be the condition? So the frictional force between the A and the B, FA is equal to, it is called as a mu mg. So what is the mu value? Is 0.2 into mass is mass value is 1 kg here and G value is going to be the 10. Okay, so this is going to be the 2 newtons is your frictional force between the A and B. And acceleration or the maximum acceleration it can attain is also 2 meter per second square. This is your maximum acceleration. Then what are the forces acting on the B here? The forces acting on the B will be one is towards the right side and this one will be towards that is frictional force. These two are again will be there. So this is your applied force. That means what should I write here? F minus 8 should be equal to the 12. From this one, F is equal to how much నాన్న ఇక్కడ మనకు వచ్చేటప్పుడు 4 twos are sorry 8 and this is 8 plus 8 16 newtons is the minimum force that is required to maximum force that is required to apply on the beam so that the A does not slip over here. An elevator in a building can carry a maximum of 10 persons with average mass of each person being 68 kgs. The mass of the elevator lift is 920 kgs and it moves with a constant speed of 3 meters per second. The frictional force is opposing the motion that is 6,000 newtons. If the elevator is moving up with its full capacity, then the power delivered by the motor is going to be how much? So for this one, so in this case, what are the total force in this? Sorry, the lift has been moving or elevator is moving. One is the force because of the weight, that is each person is going to 68 into 9.8 into. So how many persons will be there here? Into 10, sir. Maximum 10 persons. So which is equal to the 9.8 into 6.8. So or else if I instead of the 9.8 G value 10 తీసుకుంటే, then we'll be getting it as a 6,800 newtons. Second type, that is force because of the weight, that is gravitation, is equal to m into G plus NNID. So mass is how much? Mass will be how much? So three types of the forces will be there. One is an find out the total force required to move this one. So one is an force due to the each and every person, 68 persons are there. Weight is 10 newtons and multiplied with the 10. So now another case is the frictional force. Force of the friction is here as already provided, which is 6,000 newtons. And force of another case. What is another force we need to apply here? Since elevator is moving upward direction, force of friction also we have considered this one. Now what is your limiting friction do we need? Mass of the elevator we need. That is for frictional thing. That is 920 into 10, which is 9,200. So summing up of all these three forces, 1, 2, and this is 3. So if we add them, what is the net force that we are getting? What is the net force? Summation of all these things, that is 6,800 plus 9,200 plus 6,000. And that should be equal to how much? 16,000. That will be equal to the 16th thing place. So total force, then the power required to move it, power is equal to net force into velocity, which is equal to 1600 into 10 to the power of 3 into 3 into velocity is 3 meter per second. So multiply this one, that will be the 48 into 0, comma 48 3. This is your total power delivered in moving it. So now next one, please. A mass of 10 kgs is suspended by a rope of length 11 meters from the ceiling. A force of F is applied horizontally at the midpoint. So that means from a rigid support, a pendulum is been hanging at the center. You are applying a force CF like this. The pendulum is being held and it's going to be making an angle 45 degrees here. So we need to find out the what he is asking F value. So from this one, this is direction is going to be the mg and this is also theta. So that is tan theta is equal to opposite side by, which is F by mg. From this one, what can be the force value here? F is equal to mg only. since tan theta is equal to 1 or theta is equal to 45 degrees. So this is the basic thing, and mass is going to be 10 kgs. G value also 10 if I take it, so it is 100 newtons. Next, an insect at the bottom of a hemispherical ditch of radius 1 meter. It crawls up the ditch and starts slipping after the height of this one. Coefficient of friction conditions. It is nothing but a semi-hemispherical ball sort of a thing is there like this, and an insect starts crawling from bottom to top. This is your radius r, and this is your height h in the same case, or radius also you can consider like this. This will be the radius in this case, or else if I take it in another way, the same diagram, instead of considering like this, let us take the insect is been rising up to this one. This is also radius r, but this height will be equal. So this is the height where it's going to be rising above the ground. So now, for just moving condition, angular friction mu is equal to tan theta. So from this one, coefficient of friction is equal to 0.75 in the sense tan theta is equal to 3 by 5. Sorry, 3 by 4 here, or 4 by, so 0.75 3 4 by 3. So angle has to be equal to how much? It should be equal to the, that is theta is equal to 37 degrees will be getting. So from the same diagram, if I want the tan theta thing, or cos theta will be equal to the adjacent side is what is r minus h by hypotenuse is going to be the r. From this scenario, the cos theta is equal to cos 37, which is equal to the r minus h by r. So cos 37 value is going to be how much? It will be the 4 by 5 is equal to r minus h by r. So from this one, it has been proved that r value is equal to 16 newtons. Okay, so he's asking he's asking the height value. So the radius is going to be the 1 meter here. Substitute the value of the radius. 4 by 5 is equal to 1 minus h by 1, and solve this one. You will be getting h value is equal to, that is 0.2 meters or 20 centimeters. So this will be more comfortable, 0.2 meters, which is your first option. Fine, sir. Next one. An inclined plane is making an angle 30 degrees with the horizontal is placed in a uniform horizontal electric field. So that means force because of the electric field is acting in the upward direction is going to be the Fe cos theta. In this direction, it will be the Fe, and in this direction, it will be the Fe sin theta. These are the forces. Apart from this one, what are the other force will be acting? Downward force is equal to mg, which is 9.8 newtons, and there will be another force which is perpendicular to the normal reaction, that is n. On balancing this one equation, n is equal to, so 9.8 into cos 30 plus mass, that is 1. How much is going to be this one? Height is going to, mass is 1, which is equal to the mg sin theta, or the frictional force is going to be the Fe sin theta, which is 1 into sin 30 sort of it. And from this next case, acceleration A is equal to how much? So we need to find out the acceleration from this one. For that, F is equal to mu into N. Get from the force, you can get the acceleration. After substituting the acceleration, put it on in the equation. S is equal to half A t square. So substitute, we have got the distance, height is being given. So distance S is equal to, that is the hypotenuse, S is equal to 1 by cos 30. So everything, S value we have got, acceleration we have got, time is the only one thing that will be unknown. Fine, sir. So with this one, I'm closing the session, please, here. Due to technical reasons, please.